Welcome. In this overview, you'll learn how to interact with the simulation and perform each of the required combustion safety tests. To begin, select one of the 8 provided training scenarios. For this overview, we will work with Training Scenario 1. Click the Launch button to launch the training scenario. It will take a few minutes to fully load the training scenario. The simulation begins on the outside of the house. On the lower part of the screen, you'll find your clipboard, your safety equipment, some information about the house, your toolbox, and a handy teleport button. Let's open the clipboard and see what testing needs to be performed as part of your combustion appliance zone safety testing. There are 6 different areas in which you'll be tested. You can click on any item in the clipboard to see what those items are. To close the clipboard, simply click the X. Just as with real life, you need to start by calibrating your test equipment and putting on your safety gear. You put on your safety goggles and your CO monitor by clicking on them. You'll receive an information box that shows that you've put on the goggles and that you have put on your CO monitor. Equipment needs to be calibrated in fresh air before you enter the house. So open your toolbox by clicking on Toolbox, and we'll pull out the gas sniffer, which has now been zeroed out, and our combustion analyzer, which also has now been zeroed out. You can put away your tools by clicking on the highlighted tool in the toolbox. You'll see in the clipboard that we have now completed our outside checks. We put on our safety glasses, our CO monitor, and zeroed out our equipment. You move around in the simulation by using the arrow keys. You can turn right by pushing the right arrow key, move forward by pushing the up arrow key, backward by pushing the down arrow key, and left by pushing the left arrow key. You interact with the items in the simulated house by clicking on them. Click on the front door and you'll be able to enter the house. We'll perform the items in the simulation in the order that they show on the clipboard. We've already completed the outside checks, so next is depressurization testing. The clipboard also shows information in these text boxes that you can read, and there's also information bubbles. The information bubbles will give you information about the thresholds that need to be paid attention to for each of the tests. When you click the I, you'll receive a new information text that explains your threshold items. So you'll see that for the depressurization testing, our comparative benchmark for CAZ depressurization is positive or neutral pressure in the CAZ with respect to outdoors. And our available combustion air must equal or exceed 50 cubic feet per 1,000 BTUs input of all CAZ appliances. That will come in handy when we get to the point where we want to look at our work scope items. To perform our CAZ depressurization testing, we want to start with all of our interior doors open and all of our exterior doors and windows closed. Open the doors by clicking on them. Move through the house, open the doors, and check for any open windows. We found an open window. To close the window, simply click on it. The system also has this teleport button that you can use to move throughout the house. We can click on that to go upstairs and open our doors upstairs as well. Don't forget to check the windows. The next step is that we need to turn on all of the exhaust fans, including our range hood and dryer. The exhaust fans can be found in the bathrooms and in the laundry room. Turn it on by flipping the switch. You'll see an indication next to the vent whether the fan is on or off. Turn on the range hood by clicking the red on-off button. Turn on the dryer by clicking at the top of the dryer to get close and then clicking the red on-off button. You'll see an indication that the dryer is turned on. Leave the close-up view by hitting your escape key on your keyboard. The House Info button at the bottom of the screen gives you an indication of the status of the items in the house. When you click that, you'll open a panel that will show you what's going on. We can see that all of our exhaust fans have turned on, our dryer is turned on, our range hood is turned on, and all of our interior doors are now open. Our exterior doors are closed, and our air handler fan is turned off, as is our furnace. That is the state we want the house in for the first step of our depressurization testing. For depressurization testing, we need to open the toolbox and pull out our manometer. Best practice is to have the manometer referencing the outside air, the outside ambient air, through the hole provided for that in the blower door shroud. So click the blower door to set up your blower door. Then grab your reference hose and attach it to the hole in the blower door shroud. You need to move a little close to the door to get it to attach. We are ready to start testing our door positions for our worst case depressurization. You want to test the door position starting with the door that is furthest from the CAZ. So use the teleport button to go upstairs. Our door that's furthest away from the CAZ is going to be the master bathroom. You want to make sure that you are on the CAZ side of the door when you test the door. Close the door, and if the pressure on the manometer becomes more negative, you leave the door closed. If it becomes more positive, as it did in this case, you want to open the door. If you find that the pressure on the manometer remains equal when you close a door, you want to leave the door closed for the simulation. That's to avoid any rounding issues. You finish with the door to the CAZ itself. You always want to be on the CAZ side of the door when you're testing any door. So in this case, we need to step into the CAZ, which is our utility room, and close the door. So far, our worst case depressurization is negative 3.6. You can make a note of this, or you can also see it up here on the manometer itself. Now, depending on where you've been with your manometer and which doors you closed, this minimum might be different if you happened to close the door when you were on the wrong side of the door. So don't count on that. I would always make a note of what the most negative pressure is, because now we need to test our worst case depressurization with the air handler running. So open all of the doors that you just closed, move to the thermostat, and turn on the fan by clicking Fan. We want the system turned off, but the fan on. If we check our house info, we'll notice that all of our exhaust fans are still running. All of our interior doors are now opened again. The exterior doors are still closed. And now our supply and return vents are active. The air handler is running. Repeat the door closure test with the air handler on. Again, the final door that you want to close is the door to the CAZ, and you want to be on the CAZ side of the door. So our worst case depressurization with the air handler running is negative 3.2 pascals. Our worst case depressurization with the air handler off was negative 3.6 pascals. So the worst case depressurization for the house is negative 3.6 pascals. Enter that worst case depressurization onto the clipboard. When you click out of the answer field, you'll be given an indication of whether your answer is correct or not. The CAZ volume would normally need to be calculated. In the simulation, it's given as a selection. Our CAZ in this house is the utility room, so our CAZ volume is 20 feet by 30 feet by 10 foot tall, 6,000 cubic feet. We simply select utility room, and that's our volume. Now we have to determine whether or not our items pass or fail for our work scope. We know that the comparative benchmark for depressurization is positive or neutral pressure in the CAZ with respect to outdoors. Our pressure in the CAZ is negative with respect to outdoors, and so we fail because we are not positive or neutral. Our water heater CAZ depressurization fails, and our furnace CAZ depressurization fails because the water heater and the furnace are located in the same room. The volume needs to be large enough to allow enough combustion air that it can equal or exceed 50 cubic feet per 1,000 BTUs input of all CAZ appliances. We see in the notes that the furnace has 70,000 BTUs and the water heater has 40,000 BTUs. 70 plus 40 is 110, so we need 50 cubic feet times 110, which means we need 5,500 cubic feet of air in order to have enough combustion air for our appliances. We are in the utility room, which has 6,000 cubic feet of air, so our volume passes. The next item on our clipboard is ambient CO oven testing. You can zoom close to the stovetop and oven by clicking the top of the stove. Turn on the oven by clicking the faceplate of the oven controls. We want to test the ambient CO with the oven running at its highest temperature, so we're going to select 500 degrees. Take the combustion analyzer out of the toolbox, and we want to measure ambient CO at the ambient setting. You can see the little red triangle is pointing at the house with the CO, and it says ambient right here, which means we are in the correct setting. Our ambient CO is 19.8 parts per million. We enter that recorded value of ambient CO on our clipboard. Then we need to determine if the ambient CO passes or fails for our work scope. We can click the information button, and it tells us the allowable limit for CO in the kitchen is 25 parts per million. We are less than or equal to 25 parts per million, so our ambient CO passes. For vented appliance testing, we want to test spillage and CO at the water heater and the furnace. In order to test for spillage and CO, we need to turn the appliance on. Click near the controls of the water heater, and you'll zoom in close. You can turn the water heater to hot by turning the dial. Hit your escape key to zoom back out. Now you want to get close to the flue of the water heater, so click the top of the water heater, open your toolbox, and pull out your smoke stick. Hold it near the vent hood, and you will see that in this case, the flue is drafting and the spillage passes. To test for CO, we pull out our combustion analyzer. For vented appliances, we need to use the air-free setting of our combustion analyzer. So click the mode button to move the little red triangle over to the air-free setting, and we see air-free in the display. We grab our combustion wand by clicking and dragging and place it on this spot to get a reading. The CO in the water heater is 180 parts per million. We also need to test spillage and CO in our furnace. But again, the furnace must be running in order to test this. So we need to move to the thermostat and turn on the furnace. Now click the furnace to get close to it. Take out your smoke stick and hold it near the vent. We see that our furnace is spilling. So it fails the spillage test. To measure CO, we take out the combustion analyzer, set it to the air-free setting, grab the wand, and place it, and we can read our CO is 370 parts per million. Now we need to determine if the CO in the water heater and the furnace pass. Again, we have information bubbles we can click. And we see our CO threshold for the water heater is 200 parts per million, so we can select pass. The CO threshold for the furnace is 400 parts per million. That also passes. In the field, you'll also be performing a visual inspection of the flue pipes for all vented appliances. For purposes of the simulation, the visual inspection items all pass, and they've been filled out for you in the clipboard. However, there is a visual inspection reference guide available for you by double-clicking the link on this clipboard page. The reference guide gives you information about checking for blockage, soot, corrosion or oxidation, slope, termination, support of the vent, and other inspection items. You'll get information and pictures to help you in the field to determine what you're looking at. The next item on our clipboard is the unvented appliance testing. The only unvented appliance in the house, in the simulated house, is the stove and oven. So again, we click the stovetop to move close. We're going to turn on our oven, and again, we want to turn it on to the highest setting. Pull out our combustion analyzer. Unvented appliances are tested at the diluted CO value or the as measured value. So we click the mode button till we see as measured, and our triangle is underneath the diluted vent gases. Grab our wand, and we're going to place it in the oven flue. We see that our CO is 95 parts per million. We also need to test all the burners: front right, front left, and rear left. You turn on the burner by clicking the knob. We can grab our wand and place it at the front right burner and see that our front right burner is 10 parts per million. Repeat this process for the rest of the burners. Then again, we need to determine whether the oven flue and the burners pass or fail in terms of our work scope. We have another information dot here. We see the threshold limit for the top burners are 25 parts per million as measured per burner, and the oven is 225 parts per million as measured. So our oven was 95. That passes. It's 225 or less. The burners are also all passing. And the final item in our clipboard is gas leak detection. We have 5 gas appliances inside the house and the outdoor gas meter. One of our appliances inside the house happens to be the oven, which we are standing at. Click the gas line to get close to it. Take out our gas sniffer, and we drag the gas sniffer down to the dot. The gas sniffer has an indication. It will show a green light if there is no leak and a red light if there is a leak. We see our oven does not have a leak. We can reseat the tool by clicking on it and move away from the close-up view by hitting escape. The gas meter is outside on the left side of the house. We can click on the meter to get close to it and take our tool to the gas line, and we see that we do have a leak at the outdoor meter. Once you've finished all of your clipboard items and finished all your checking, you can submit your results by clicking Submit at the bottom left of the screen. You'll be told to press End if you've completed the simulation and you're ready to submit your score and return to the course page, or cancel if you've accidentally hit the Submit button. We're going to click End. And you're shown your scorecard, where you can see how well you did on each of the areas. You can also click this little caret to open up each area and find out what the answer was supposed to be in case you missed it. Best practice is to practice each of the 8 scenarios and continue to practice them until you can consistently get a score of 85% or better. The different scenarios will provide different results, and they have different types of heating equipment as well, so you want to practice on all of them.